right, hi everyone. So now we're going to learn about step functions. And step functions are those functions that I showed you in the last standard where they create little steps going either up or down. Now there's two different types of step functions, and you do need to pay attention to what your equation looks like. There's a floor function and a ceiling function. Now, floor, these are different than absolute values because there's little hooks on the ends of these little symbols here. A floor function has a hook on the bottom, whereas a ceiling function has a hook on the top. Now a floor function, this parent floor function is the most basic floor function. It's going to look like this, where you graph your points in a linear line starting at 0, 0, and you have a slope of 1. And we're only going to graph 3 steps, but you can graph as many steps as you want. And now a floor function opens to the right. And how you can remember this is that the word floor has an R in it, so does the word right. So all your steps are going to open up to the right, meaning that from your points that we have graphed right now, we are going to draw a horizontal line so it stops directly under the next point, and then there's going to be an open dot on the end of that step. So again, draw a horizontal line till it gets under the next step, and a horizontal line on the, an open dot on the end of that, and then same with this one. Right? So it's like you're walking up steps to go upstairs. Now a ceiling function here, same thing. We start at 0, 0, and then we have 1, 1, and 2, 2. But this time, this is a ceiling function, so all your steps are going to open to the left. So this step up here, is going to have a horizontal line. This step here, horizontal line, and this step here, horizontal line, and then all the open dots are on the left. So we have a set of stairs that looks like this. Now, with floor and ceiling functions, basically what you're doing in floor functions is you're always rounding down. So if I were to do an X and a Y table, and I picked the X values of 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, and 0.9, you always round down with floor functions. So if I asked you what was the value of y in this floor function when you have an x value of 0, well, that's going to be 0. What's the value of y when x is 0.1? That's going to be 0, round down always. What's the value of y when x is 0.2? 0. When x is 0.3? 0. When x is 0.4? 0. When x is 0.5, normally we would round up, but with the floor function, we always round down. So we get zeros all the way up to, if I have an x value of 1, then our y value is going to be 1 here, which is why this bottom step extends from 0 all the way to 1, but we have an open dot on 1, which means that it's not actually 0, the y value is not actually 0 at that point. The y value when x is 1 is 1. And we start our next step. So same thing for ceiling functions, but in ceiling functions, we always round up. So if I have an x value of 0 and 0.1 and so forth, same exact thing here. I'm just going to pick all the same x values. This is just an example to show you what's actually taking place here. Okay, so if I have an x value of 0, well, it's a whole number, so we just have a y value of 0. But if I have an x value of 0.1 and it's a decimal, then you round up always. So this rounds to 1. 0.2, we round up for ceiling functions. That rounds to 1. 0.3 rounds to 1, and so forth. We can round each of these to 1. So we aren't necessarily following the normal rounding rules for ceiling and floor functions, but basically what this is saying now, if x is 0, y is 0, which is true, we have a closed dot there. But we put an open dot on 0 up here. If x is 0.1, y is 1, so that's starting to create this step. And then if x is 1, y is 1. So that creates our full step, that middle step there. That's basically what we're doing here. But you don't need to know that in order to graph ceiling or floor functions. We could actually use the same exact rules for the absolute value functions to help us graph step functions. So h and k is your vertex, a over 1 is your slope, and 1 over the reciprocal of b is your slope if you have a b value. So let's get started. Looking at number 1, my steps are going to start. I'm not going to call it the vertex. I'm just going to call it the starting point. They're going to start at your hk value, which my hk value here would be -4, my k value 0. So I have a -4, 0. This is the start of my steps. Now, my a value is 1, my b value is 1. That just means your slope is 1. So I go up 1 over 1, up 1 over 1. I'm only requiring you to graph 3 steps. Now, the hook is on the bottom, which means that this is a floor. So starting from each of these red dots, we're just going to draw a step horizontally because it opens to the right. So we're doing it to the right. And then we draw an open circle directly underneath the closed circle of the next step. So in number 2, same thing. My start is my hk value. So in this case, my h value is 0, my k value is 2. So 0, 2 is the start of my steps. My a value is 1, my b value is 1. So I go up 1 and over 1, up 1 and over 1. So these are the bases of your steps. Now this is a ceiling function, which means each step's going to open up to the left. So I'm going to start at the top one and open up to the left and draw an open dot directly above my next closed dot. So my steps look like this. All right. Now, number 3, this one's a little interesting. We have a starting of 0, 0. So it starts at 0, 0. And now I have an a value. And if you recall from the absolute value lesson, your slope when you have an a value is your a value over 1. So that means I go up 3 and over 1, up 3 and over 1. This is a floor function, so each step's going to open to the right and end directly underneath where the next step starts. So basically what we did was we did a vertical stretch, and that means that each of the steps are going to be spread out further away from one another. In number 4, your start values, your hk again. Oops. Which in this case is 0, 0. So the steps start at 0, 0. I have an a value. Remember your slope, and you need to be careful with this one. Your slope is your a value over 1 always. So I go up 1/3 and over 1. Up 1/3 and over 1. And if you want to do another one, up 1/3 and over 1, that's not a bad idea because then we get to the next whole number. This is a floor function, so all my steps are opening up to the right and ending directly underneath where the next step starts. Now we should notice that this was a vertical because we have an a value. It was a vertical compression. So all my steps got really, really close together. So if you have a vertical stretch, all your steps get further apart. Whereas if you have a vertical compression, all your steps get really close together. Now in number 5, I have a b value, which I start still at 0, 0. But a b value, remember, is either a horizontal stretch or compression. In this case, it's going to be a horizontal compression. But we don't even need to know that. all you need to know is that your slope is going to be, since it's a b value, it's going to be 1 over the reciprocal of b. The reciprocal of b here is a 1/2. So what that means is my rise is 1 and my run is 1/2. Up 1 and over 1/2. This is a ceiling. So I'm going to open to the left, and each of these steps are going to be very tiny. They're going to only be 1/2 of a unit long. And that makes sense, because if this was a horizontal compression, that means horizontally your steps are going to get smaller, which is exactly what happened. In number 6, same thing. We start at our HK value, which in this case is going to be 0, 0. And now I have a B value, so this is going to be a horizontal, in this case it's going to be a horizontal stretch. But since you have a B value, your slope is going to be 1 over the reciprocal of B. The reciprocal of a 1/2 is a 2. So this means I go up 1 and over 2, up 1 and over 2. Now be careful with this one. This is a ceiling function, so we're going to open to the left. But again, your step goes all the way till it meets the starting point of the next step. So each of these steps are pretty long. They're 2 units long, which makes sense because we had a B value, which is a horizontal stretch, meaning that horizontally the steps are going to be stretched out, or they will become longer. All right, moving on to the next page here. So number 7. My start is going to be my HK value. My H value is 1. Remember, your H value is always the hard one to remember. My K value is 0. So this is the start of my steps. Now I have an A value, and so my slope is going to be my A value, which is 2 over 1. So that means I go up 2 and over 1, up 2 and over 1. This is a floor, so my steps are going to open to the right, and the steps are only the length of up to where the next step starts. All right, number 8, my starting step is going to be at -1, 0, my HK value. So that's this point right here. My A value is 1, my B value is 1, so my slope is 1, up 1 over 1, up 1 over 1. This is a floor function, so all my steps are going to open to the right. All right, now this next one's a little bit tricky because this is really a reflection over the x-axis. And let's write that down. Sorry, reflection over the y-axis. So what this means is that if I had my parent function, which the parent function is up like this, and if it's a ceiling, it looks like this. So this is my parent function. What's going to happen when we do a reflection over the y-axis is all of these steps are going to reverse. So now it's actually going to become a floor function, like so. So all of these are going to flip over the y-axis, all those red steps. And I'm going to erase the red steps because that was my parent function. But that's really what happens as it reflects over the y-axis. Looking at number 10, my start is at 0, 1. My A value is 1, my B value is 1, so I go up 1 over 1, up 1 over 1. This is a ceiling, so I open all of these up to the left. All right, I'm going to have you do number 11 by pausing the video. Okay, so here's number 11. Now I'm going to save number 12 for the next video. We'll do 12 through 18 in the next video just to get some more practice with step function.